Robert sir has joined, sir.
Roy ji, good evening. Shall we start?
Yeah, we'll start.
Okay, then formally I'll just get the ball rolling. Good evening to all of you and welcome to this evening's lecture organized by this Young Engineers Forum of Indian Society for Non-Destructive Testing, ISND Tirunelveli chapter. As our dear members are aware that we have been organizing regular technical and non-technical lectures also on this platform. Our Young Engineers Forum is a very vibrant wing of our ISND Tirunelveli chapter. And this chapter has a lot of heritage in organizing all the technical talks and has been one of the very vibrant chapters of ISND in the country itself. And we are proud to have a very vibrant Young Engineers Forum also. This is actually taken care by, in fact, all the stalwarts who are later come to this higher positions in our chapter have been earlier associated with the Young Engineers Forum. And the present team of Young Engineers Forum is also very excellent one, and they have been regularly selecting very good speakers on topics. And today we have our Deputy Project Director of Test Vehicle Project, TVP of ESSC ISRO, J.Paul Murugan. He actually has been a very active member. He's been very vibrant in all our technical societies and has been really contributing well in the projects as well. And today we have a very interesting topic, recovery and reuse of rocket stages, which is actually beneficial to many of our student members. That is, we have quite a number of student members also attending today as well as faculties. So I would just like to welcome all our dear ISND fellow members, our executive committee members, senior members. I have seen quite a lot of our senior executive members. Good evening, Adil sir, and others who have actually found time to join us. So with this brief introduction, I'll hand it over to Girish, our secretary, to carry out the proceedings. And let's have a very useful and an enjoyable evening. And let us all get technically benefited out of all Murugan's knowledge about the subject. Thank you. And once again, welcome all of you. Over to Girish, please.
Thank you, Chairman. Now we'll now invite Ravina sir to give a brief introduction about the speaker and then hand it over to the speaker.
Okay, am I audible now?
Yes, sir, you are audible, sir.
Okay, so good evening to all. Today our speaker is, one second. One second. Today our speaker is Sri J.Paul Murugan. Sri Paul Murugan has joined VSSC during the year 2004 and completed his MTech in machine design from IIT Madras during the year 2010. And currently he is working as Deputy Project Director in the Test Vehicle Project. He is responsible for the realization of structure and propulsion systems. And before moving to the project, he was working in Solid Motors Group, where he was involved in the design of various solid motors, including 3 special type of CES solid motors for the pad about test flight. He has 3 patents as main inventor and has 40 publications, including journals and conferences. He has attended and presented paper in International Astronautical Congress in Australia during the 2017. He has received numerous awards like ISRO Young Scientist Award in 2011, ISRO Team Award in 2018, SBF Best Idea Award, and many paper awards. Today's topic is recovery and reuse of rocket stages. The talk covers currently available recovery approaches, impact of cost due to recovery, cost analysis, and comparison among rockets, technological challenges, and the requirement for design of recovery vehicle, recovery process of SpaceX, Blue Origin, and Virgin Galactic rockets. Also, it will be covering the recovery process space shuttle using parachutes. So with this introduction, let me, on behalf of the Young Engineers Forum, welcome Sri Paul Murugan for this presentation.
Sir, shall I take? Yeah.
Yeah, over to you, sir.
Respected seniors and my dear colleagues, good evening to everyone. So first I thank ISNT for giving me this opportunity. A special thanks to Grace Nambudri, Mount Mercer, and who was introduced to me. I didn't get name clearly. Thank you, sir. So today my topic is already sir explained about what is the content I'm going to talk. Today topic is recovery and reuse of the rocket stages. So we know the last 50 years, so we are launching by using the high performance rocket to launch the payload, but the cost very high because that rocket is expendable. And also now if you know that global space industry became commercial like automobile, so hence reduction of the cost in any form for any space industry is very important. So that's why now current trend is that high performance optimum vehicle to low cost, highly reliable and environment friendly vehicles all are moving to that low cost vehicle. So we all know that 70% of the recurring cost from the rocket is tri-mass or inert mass system like propulsion systems, structures, tanks, and avionics system, etc., which never reused because of expendable vehicle. Also, for realization of any engine or structure, we need material cost 60% and fabrication cost 40%. So then how to reduce the cost? Either we have to go for the low cost material or we have to go for the advanced fabrication method like 3D printing, friction stir welding and flow forming method, etc. And also very important, the defect-free components we have to fabricate because we are going to recover and again we want to reuse, means that is very, very important. So once we realized, then low structural factor stage or low inert mass of the rocket stages, and also that engine, especially high thrust weight ratio engines, is very important. If all achieved, then recovery and reuse is very simple. So currently, we all know that the SpaceX Blue Origin is successfully employing this recovery reuse by using the vertical takeoff, vertical landing, and by using the retro propulsion method. The first Blue Origin, we all thinking that SpaceX only first recovered, but Blue Origin only first in the November 23rd years recovered, but that is a suborbital vehicle. It went up to 100 kilometers, they recovered. Immediately next month, that same year 2015, our SpaceX is put the satellite in the orbit, then recovered. That is orbital launch vehicle, he has recovered the first stage. That's why it made a history at the time. And also one more person is there, he is Virgin Galactic. He is also continuously reusing the his aircraft with conventional rocket for launching the crew transportation. He is not putting any payload, only for space tourism. So today I am going to talk about SpaceX, Blue Origin, Virgin Galactic, and their cost impact, how they are the cost is affecting the launch vehicle cost, and also how they are earning the earnings from their reusers. So we know these are the recovery methods. Earlier days, they used to do parachutes and again inflatable aerodynamic decelerator and retro propulsion with the VTVL approach. Now our Starship SpaceX person is using robot chopsticks to catch SpaceX these Starship rocket when it is coming to the first stage, using the retro propulsion. Instead of landing leg, he is trying to catch like that. This is a schematic idea only. And here we arrived from this Japanese robot ISS. This is the model. It will come, this arm, it will go and catch and hold here in the ISS. Based on that one only, he has tried here. And this recovery method is not new. Even 1960s itself, Philippe Bono is investigated lab level test, smaller engine level test, and he has found that it's a small rocket also he used, and he found that some payload advantage is there because of the recovery. But he tried with a single stage only. And VTVL advantage compared to other method is this will give a very, very less inert mass with controlled descent using the throttable engine compared to surface area or aerodynamic braking like parachutes, etc. That's why VTVL, vertical takeoff, vertical landing, is very popular among space industry. So difference between liquid solid. The solid engine, we all know that it is once fired, we cannot stop. There's no restart capability. But the liquid engine, it is possible to varying the thrust from 100% to at the lower level. How much we can go lower level, it depends upon propulsion capability and many factors there. That also I am going to cover in this lecture. So I already told the thrust to weight ratio of the liquid engines, that is very important. If you see here, earlier 50 years of space history, a very powerful engine developed by Russians, Americans, like semi-cryo engine or liquid cryogenic engines. So if you see here, thrust to weight ratio, all are less than 100 only. No engines crosses above 100. SpaceX, Merlin only 180. So these all are the RD-180, a Saturn F1 engine, then Space Shuttle RS-25. These all are the very famous engine, successfully gone in the launch vehicle. But thrust to weight ratio is very less. Currently, SpaceX is developing one more Raptor engine that also is a high thrust to weight ratio compared to this number. For example, for getting the idea, our Vikas engine, if you take thrust around 790 kilonewton, 80 ton, mass is 870 kg. So VR is also 92. Our Vikas engine also is more than that thrust to weight ratio. Thrust weight of other engine. If we further we will optimize our engine, ours also it will cross above 100. So why this recovery and reusability? So Space Shuttle in 1970s they developed especially for fully recoverable purpose only. But unfortunately, that is partially reusable. It become, but very very high expensive for taking astronaut or any component. They paid $1.3 billion for one vehicle. Means 1.3 means 1,000 around some 13,000 crore it will come. So that's why at the time all space industries they arranged meetings and they want to reduce the cost. They studied that reusable single stage to orbital launch vehicle we can go, that will get advantage. Like that they started. That is a very very important project, that one National Aerospace Plane project and X-33 project, TC-33. All these project they developed, and TC, this is the thing. TCX the first flight also they launched, but they are unable to put the payload in the 300 kilometer orbit. Whatever the target they have not achieved, that is the reason is the technological immaturity and there is no enough fund availability at the time. That's why all the these projects they dropped out, they closed single stage to orbit vehicle conditions. Similarly, this one Corona 2012 also he has developed, put 500 kg in the low Earth orbit. Yes, this is schematic. He has spent a lot of money, but finally unable to achieve with respect to. Similarly, Soviet Union's N1 very very high mass they tried to catch with parachutes also, but they were not successful. So now coming to the SpaceX, after 2000 we will take space industry, before 2000, after 2000. So the SpaceX has come and he has developed Falcon 9 vehicle, started with the Falcon 1. So this is the successful vehicle, same like a modular concept. First stage with the 9 Merlin engine. Yes, this is station point same. He will put is a crew Dragon or cargo Dragon. Taking the experiment to ISS, he will put that capsule is different. Similarly, for satellite launch, you will put a payload fairing inside the satellite, you will launch. And here, if you see here, first stage recoverable. This first stage with 9 engines. And he has recovered payload fairing also many times by catching through net in the seaside. And so he able to, similarly cargo Crew Dragon also, whenever launched, he able to recover the first stage rocket. Currently, now he is developing one Starship rocket. This is a Starship rocket. Many times we heard about the Starship. What is the meaning Starship means? It is consist of super heavy booster. This is called a super heavy booster. This is called a Starship. They will call second stage or Starship spacecraft. Satellite like that also they will call, because they are going to use for many purpose. This is a super heavy booster. They will call us booster BN SN series, like that they will call. Both stages is recoverable. So we might have seen many news or videos. Last time also, this super heavy booster he has tried, but it was failed. But he never worried about that one. Continuously is doing prototype flight, and this is successfully he has done, and up to some SN15. And this also well proved. Now he is waiting for Federal Aviation Administration (FAA), that is one agency in America. He has to give approval. So last June he has moved to launch pad, but again they didn't approve. He brought back. So it is this is the this is a high. If you see the comparison, whatever available vehicle, the Starship vehicle only You see here 7,210. That is the thrust, lift of thrust it will give. Compare with the Saturn next, only half of the thrust only it has given earlier. Similarly, lift of mass also, if you see, almost double. So this is a powerful rocket, is going to rule the space industry in the coming years. That we will see how it has developed and up. Then I already told the single stage orbit from Earth to launching the low Earth orbit or space. It was not successful, but successfully earlier they have done on the away from Earth. That is, this is one of the main one, throttable. They have done the liquid LME. That's lunar model descent engine. So they went here lunar orbit and successfully landed and came back. Same kind of thing also now. The SpaceX, the Starship, I already told the Starship second stage, they are calling as a space second stage and also spacecraft. So this is by using that Starship rocket, we all heard about Artemis program for NASA. So what is they are again, they want to go to moon. Earlier, 1969, they went to Apollo mission. Then again, they want to go back, but now this time they want to go different method, not like earlier method. So what they are planning, this is their SLS rocket. So here Orion crew model is there here. So we can go up to 9-member to 10-member. They are having the different version of SLS rocket, and they will take astronaut to lunar orbit. It means not inside the moon surface, outside lunar orbit. Here they are planning to construct a gateway one space station. So this is the schematic. This crew model Orion, it will go and astronaut, they will stay here. Similarly, SpaceX also will launch this through Starship, Super Heavy booster rocket. They will take this Starship. The Starship will be landed here, positioned here, and from there they will go to lunar orbit to moon surface or lunar orbit to they will go to Mars. So continuously they want to transport more than 100 times. So what we have to do fuel from there, once we go, the fuel it will be over. That also they are planning like this. Tank, refueling tanks, this is. So they will transport this tank in the same vehicle and continuously it will go on the refuel here, gateway substation. From there they will go to continuously flight. But now we all heard that when Mars is going, there methane, lax methane engine only here he has developed. So that is available methane there. So he is telling that I will refuel for coming back. When only going only he has to refuel like that. Elon Musk is telling. So how much it will be successful we don't know, but still he is able to fill this tank going upward and downward also from lunar orbit to any interplanetary orbit. That is his target. By looking that one, we'll see that this and all is it possible or not. But really, the way they are working, it is possible only because that NASA itself given $3 billion to SpaceX for developing Starship HLS reusable rocket, that is human landing system. And this also SpaceX has competition with Boeing and Dynetics, both are in American companies. From that one only, finally that contract he got succeeded. So this is the future that Moon and Mars. Parallelly, Elon Musk also working. He wants to go to Mars colony, continuously transporting human to the Mars. For that also, he is going to use the Starship rocket only. So this is the 6 Raptor engines configuration. The space economy. So many times we heard about the space economy is booming like that. For understanding to everyone, just I am telling that today is that $1.80 rupees. So when we are telling $1 million, 8 crore. $1 billion is 8,000 crore. Similarly, $1 trillion is 80 lakh crore. So now the space industry, I already told it is commercial and that economy, it is giving economy to any space industry. Whoever is successfully is doing the low cost rocket. So here $424 billion is nothing but 34 lakh crore. That much money involving in the space industry. It is nothing but India's last year budget 32 lakh crore. So 1 year India's budget, that much economy is there in the space industry. And coming to the Americans, India's GDP $3 trillion. We know that after independence, to get to $1 trillion economy, we have taken 35 years. The next second one around 25 years. Last only we have taken 15 years. So similarly, American $23 trillion. Now the SpaceX, what he is going to do, he is going to launch Starlink satellites. That is satellite-based internet, very high speed is going to give. America already some people are getting. And what is planning? Starlink satellite, one satellite to 260 kg. So he will launch 60 satellite. This is the stacking inside the payload bearing, 15.6 ton. So that later I will tell. So that recovered first stage Falcon 9, he will use for launching this one. First, he recovered, he is telling that 20 times he can use that single stage recovery, reuse. So he will use 5 times for commercial launch, remaining 5 times for launching in own satellite in the free of cost. So that way he is going to get nearly a next within 3 years. The FAA also has given approval to the 12,000 satellite. Sorry, this is wrong. The 12,000. And another 5-6 years, 40,000 satellite is going to put to low Earth orbit for giving the internet to global. So from that one, his target is $1 trillion direct contribution to the US economy. So that is only his target, one of the target, in addition to Mars colony or whatever technology support for the advancement in the space arena. So again, the recovery of the first stage in the crew transportation vehicle, we all know space shuttle at the time when they launched, they tried recovery, but they were not successful. But when we are going to launch now, China, if you take or Soyuz, they are going to launch crew means so much health monitoring with respect to crew they will employ. They never thinking about the recovery of first stage. And again, if you want to recover in the crew transportation, you have to pre-plan whether I'm going to recover or not in the stage. Recovery means you have to put all the systems in the bottom, landing leg, corresponding systems, and corresponding guidance related. So much thing you have to put for this recovery also. So SpaceX and Blue Origin also, they decided they want to recover in the crew transportation vehicle also. But how it is possible? So this is the difference crew escape system. This is called the pusher type escape system. That means the crew module will be sitting on top of the vehicle. It will not protected with heat shield or any other crew module fairing. It will be open to atmosphere. The lift up to, it will go to up to 400 kilometer orbit. It will expose to atmosphere. But here, this is a puller type or a tractor type or about tower we will tell. That is called the CS system. Here, crew module will be protected inside, and again for taking that one so much a solid motor. So this total mass it will come around 25 to 30 ton. But here within these crew module 8 to 9 ton SpaceX crew module, and Blue Origin around 10 ton, 9.5 to 10 ton. So he is putting here. This also it will work crew escape system. Super truck engine he has put here. It will take at any altitude, any about condition it will take. So that's why if you see here. If puller type escape system means you have to recover CS, because CS after 70 kilometer we don't want if it is crosses atmosphere region. But if when you put this puller type system, you have to escape this first after 70 kilometer only first stage rocket also it will separate. So you have to recover first stage at the same time these should not come interfere. So you have to use a different trajectory to bring these both. That's why it is not possible in the puller type system. It is not possible in the sense it is a very complex recover. So, but the Blue Origin and the SpaceX, if you see here, they are able to recover because of it is sitting in the top side. And based on that one, first launch, we all are in Corona time. He has launched first Crew Dragon Demo 1 flight. He has not recovered, only recovered the crew module and kept in the separately. And first recovery. The second time when Crew 1 launch he has done, successfully he has recovered this first stage. Again reuse second time also in Crew 2 flight April 21 he has successfully launched recovered booster fully, whatever recovered fully reusable booster he has launched, and I will tell later one booster cost is around $30 million, 250 crore. And again he has used this Endeavour crew model also. He is with the minimum refurbishment he has successfully launched, that made a history. And coming to the NASA, whenever NASA want to launch a military satellite, they never go with recovered booster or used booster because they never trust very confidential. But that's why they used to give to Delta rocket, very costly. But later after seeing this one, now NASA military satellite also given to SpaceX, even fifth recovered booster also they used to launch a military satellite. That way they made history. Similarly, our Blue Origin, these all be new Shepard rocket. This person also, he never put satellite or payload in the orbit. His target is space transportation. Up to 100 kilometer altitude, he will take tourists and he will bring back. And this is the suborbital vehicle. And here he has given that that windows and all very good window for space, attracting space tourists. He is telling 10 times he can use a year. But SpaceX is telling I can recover 20 times. Successfully, he has done 13th. But he has proved only as a 5th time only. And this cost per crew, initially first he has put through bid, he got $28 million, around some 280 crore. But later he is charging, he is not disclosing how much it cost, but what we can tell that his development cost is $6 billion he has put for making this technology. So definitely to get this break even, he has to launch every week 6 people. That means 300 people in a year he has to launch. Then only break even will come. So based on that only he is going to put this cost per crew. So now he is telling nowhere it is disclosed. I feel it will take minimum $10 million for this space transportation. Even though he is recovery reusing, but development cost he want to get means he has put like that. He also successfully first crew he has sent. But this vehicle totally 26 people still now. But one more very important for this vehicle means this autonomous flight, no pilot required. Lift up to going to 100 kilometer orbit, it will come back automatically, no extra pilot required. Then another Boeing Starliner, this also another Starliner is a crew module. He don't have rocket, so he has to depend upon American ULA launcher only. So Atlas is a United Launch Alliance rocket. But here we all know Atlas, the RD-18 engine is employed. That's a Russian engines. That is not throttable. We cannot recover. So that's why Boeing will launch using rocket, no recoverable, very high cost per astronaut. If it is employing recovery only, it is possible. And also Atlas rocket 6 people can go, but NASA nowadays is not accepting to travel more than 4 astronauts. So use maximum 3. They able to send only 1 or 2 only because of space shuttle tragedy. If one time something happens, 7 people will die. So that expertise, whatever they are giving training, they are losing. That's why they are giving 4 only. So this also, if you put to 4, is cost if you take very high. Boeing Starliner with Atlas rocket. So this is the cost per crew. Space shuttle we are now very high. $1.3 billion. One crew they charge very high. And Atlas now I told here not at a fixed, but the cost of vehicle $345 million. That means it will go to $90 to $95 million. Soyuz after space shuttle retirement, because they don't have the crew transportation vehicle, they depended on Soyuz only. So that's why since it's a monopoly, Russians charged a very high rate, $90 million. That vehicle cost itself, I think online I have seen $80 million, but per astronaut he has charged $90 million, almost double up the profit. Falcon 9, it is $55 million only. This is for 4 crew. If he is also having 6 capability, later he may put 6 means further it will come down. And SLS, that also very high cost for our Chinese also very high. For our Gaganyaan also, I have taken $55 million is vehicle cost. If you take crew module cost also, we may go to more than 90-100 only. High, but very near to SpaceX it will come. Then this is Starship rocket. This is also both stages recoverable. So Elon Musk is planning to give $3 million or $4 million. 100 people able to travel to ISS. So that is his target. That is similarly for launching the payload also he will go for with minimum dollar per kg. So these are the crew transport related recovery vehicle. Once we will reuse recover, then we will get the cost per astronaut less. This is I already told these all vehicle other than Boeing and other than SpaceX and Blue Origin, these all are prototype. The recovery is very typical. Even Soyuz also liquid stages only is having, but this recovery is very difficult because strap-on is there for strap-on. He cannot recover individual strap-on. And also one more important liquid vehicle, that is liquid escape system only it is there. That is enough because liquid vehicle, when an explosion will happen, it will not go and catch the crew module. That's why they are having the crew module with a smaller thruster, smaller in the sense space is having 56-ton thruster divided by 8. 4G only it is enough for them for escape. But whenever solid motor is there, like Soyuz or Gaganyaan, Chinese Senjus, Orion, NASA's SLS, all solid motor is there. Solid motor, if anything happen in the first stage explosive, it will catch very high. That's why they all are going for 8G requirement. That's why high power LEM CJ motor is required. So coming to the Virgin Galactic, so this also is having the hybrid motor in the bottom side. This is the hybrid motor, that is HTPP with the N2O, 31-ton thrust, burn time 60 seconds. So here, this is the carrier aircraft. 2 pilot required here, they will operate. Here also, the trained pilot required. It will take 12-kilometer altitude, this aircraft. It will take 12-kilometer altitude. It will drop this is called VSS unit, Space Plane 2. This hybrid, it will drop 12 kilometer, then it will ignite and it will take to 100 kilometer. Was not unable to reach because 90 kilometer only this rocket capacity. Because a hybrid, the bound it will change, sometimes 95, 90 like that. He never crosses 100. That also debate is going on. Really he has reached Karman line like that. So 12 kilometer. He is using also that is horizontal, like aircraft, horizontal take up, horizontal landing method. And again, he is also planning to use, he is telling 20 times this hybrid rocket refurbishment. But the problem is hybrid, when it is going with respect to, it is not environment friendly. And also this is no crew escape system is there. Earlier they have lost 2 pilots because of failure of this drop, while dropping busted this one with the hybrid motor. That pilot was sitting here, 2 people died. So that's why, since crew escape system is not there, he is trying to attract the customer with per crew $250,000. And now he increased to $5 lakhs. That means $0.5 million. But Blue Origin is he is telling $1 million, but still higher than this person. But there is a crew escape system is there. So many times we came across what is the cost of the rocket. One newspaper, when we see he will put some other rate, one person put some other rate. Here, just want to inform you, this is one cost estimating tool and models available. That is called COTS method. This is a COTS. In that one, so many model is there. That is freely available, and also we have to pay and get this model. In that one, transconst model, that only NASA also using for estimating how much cost required for each rocket. Based on that only, he is paying to other like your United Launch Alliance, Boeing and Lockheed Martin. So here also, this also is telling that the transcon model only estimating an economic optimization of space transport system. Based on that one, this is I got from one literature, one person from France, MS thesis report. I have taken from that one only. So he has estimated this so much factor, considering system engineering integration factor, technical development factor, technical quality factor, so many factor. Another important one, the commercial venture factor. So he is telling clearly, if it is a private company or government company, the cost is different. The government means so many formalities, the cost is higher. Similarly, launch vehicle type factor, which launch vehicle, suppose cryogenic means you need the propellant servicing everything, but earth storable not required, there also cost is different. Similarly, assembly and integration factor also cost is different, transportation all together. So he has estimated for the SpaceX vehicle 2011 NASA estimated with available data, but now 2020 he has taken from thorough literature, and he has found what is the cost of one Falcon vehicle. That also we all know that it is also development cost, production, operation cost, all it will cover with respect to factor. This is the handbook. These are references available here. Based on 2020 data only, he has estimated. Then reusability cost separately, that is recovery and refurbishment. The both he has, that also he has considered. And the refurbishment cost means very, very important factor. How many times I can reuse, that nobody is disclosing. That is after every flight only they are telling whether I can use or not the second time. So that also he has taken 10 to 20 and varied, and based on that one, development cost for SpaceX. I think Elon Musk put so much money, but SpaceX, how much he has put, it is not clear. But definitely it may be $8 billion. Similarly, manufacturing cost also around $59 million. And operational cost also, direct operation cost like ground operation, propellant, flight and mission operation, etc. $12.5 million. And indirect cost like servicing, staff and administrative personnel, technical support, etc. That is coming another 5, totally $17.5 million. So now price per flight of Falcon 9 rocket is estimated. That means total vehicle production cost, direct operation cost together it is $76.6 million. That is a price. That means cost for production. Then he is fixing some profit amount, means 83. Then insurance also, if you take all together, $87 million is estimated. So now coming to what SpaceX is informed to industry, that he is telling this is the recovery and reuse cost he has given. What he is telling, first stage is telling that launch means for fabrication cost $55 million. One Falcon 9 rocket, but he is giving for customer $62 million. That means $11.5 million. Even first launch itself, he is getting profit. So first recovery launch means he is losing the payload. So second launch, he is recovering the first stage. The second stage is fresh, and fairing also he has recovered initial days, but nowadays he is not recovering. That also zero. The refurbishment is telling $250,000 only. In Indian rate, if you take 0.25, 1.6 crore only refurbishment cost he is claiming. So altogether, second launch, if you take, he is fixing $50 million, but his actual cost is 15.25 only. He is getting $34 million. Then same third launch recovered first stage he is using for third time. At the time also he is giving $50 million only, because customer is very happy. 62 to $50 million he is giving. He can give 40 also, even he can give 62 also, but still he is giving $50 million. All recovered booster is giving 50 only, which is very, very lower than any other country. So he is getting $29.25 million. Like that, if you put 10th, at the end of 10, he is getting $302.25 million. Today, 80 rupees, if you take 2,400 crore. The payload pairing is not recovering, means it is only $27.5 million it will go. Still is getting around 2,200 crore. This is a reference I have taken these all details. This is again, I have given the split up. First launch, how much cost first stage, $30 million, like this 7.5. And the second launch. So the first launch means first launch, that is recovery means you will first itself you will decide recovery means you will put a landing leg corresponding system. If suppose that is failure means if you're not able to recover, loss $30 million. In addition to that, payload loss also it will come for him. This is the next I will show. So this is the cost of Falcon. And now this I have worked out based on that one. Total cost of Falcon 50.5. That is the actual cost. The first stage is $30 million. You estimate 60% it will come. So second stage is $10 million. It is nothing but 20%. So this 9 engine you see here, powerful engine cost he has given Merlin $1 million. Remaining all other powerful engine 25, 30 like that. This again, this Raptor is SpaceX Starship. He is trying to give $2 million, but the thrust is 3 times higher than Merlin. So this is a Blue Origin. Again, is coming very near. Remaining all engines are cost. Based on that one, if you put it is coming 9 engine, $10.8 million. The tank is going for friction stir welding and lithium aluminum. Very high cost that is. So remaining, if you put tallying, so payload fairing $5 million. So it is possible to give $50.5 million based on recovery. So now coming to the expendable rocket and recovery rocket difference. So Falcon 9, if you take expendable rocket, is earlier estimated around 86, is giving $80 million. And payload 22.8 ton expendable rocket. If you go for the recovery rocket, since he is putting all other system, 15.6, 30% reduction is there. Similarly, 8.3 in the expendable is getting 5.3. Cost 80 and already I told 62. So if you see here 3510, Leo and 9640 for GTO. And recovery rocket, it is higher in the first launch, but in the second launch, he will get profit. So if you comparable here, Delta 4, okay, our Mark 3 is very near to here, 5,500 and 3510. Atlas rocket and all other expendable rocket very high. Here and all recovery is not possible for other vehicle. The impact due to recovery and the reuse of Falcon 9, I already explained that is 80. First launch is getting loss only 3510. When he recovery, first recovery rocket here, his cost is higher. So that's why many times recovery is it helpful or not. We have the doubt whether is it really worth or not. SpaceX has proved that third launch $3,125. Similarly, if you put other one, it will come lower than only compared to expendable vehicle. But actual cost, if you take $20 million only, that is already I explained that 1,300 only will come. But globally is dictating that first launch is not getting profit. Second launch only is getting profit. Similarly, GT also, if you take first launch expendable rocket means 9650. But nowadays, there is no the word expendable with the SpaceX. Always recovery only is going. Even it is not recovered first stage, he is not getting any loss. Then recovery rocket, whatever recovered rocket means he is getting 11,700. But the second launch recovered booster when he is using, he is getting $9,450. Still, this value very, very lower than any other launch vehicle in the world. So that's why is getting 9,450. The highest is Delta 4 heavy vehicle. Always NASA used to give them for launching the military satellite. So now coming to the, if I am going to do recovery means, so we have to design the nozzle and how much thrust required for the re-entry. We are familiar with the thrust in the ascent vehicle. That is, it is going ascent vehicle, will reach sea level thrust and vacuum thrust. First stage, it will go to 70 km with 2 km per second. Re-entry time, I want to reduce the thrust means I have to reduce the chamber pressure and corresponding thrust also. When I am reducing the chamber pressure, the nozzle will undergo flow characteristics and lateral load, side load, the engine control system and performance of the engine, everything we have to consider while designing the recovery engine. This is the, and also this is with respect to altitude while going up and return also corresponding altitude density of air it will change, that also we have to consider. This is our fundamentals. That is, if I am while ascent base, if I assume chamber pressure 100, PE greater than PE under expansion, no problem, it will work. Similarly, exit pressure 1 bar, when atmosphere pressure reduces with respect to altitude, it will happen like this, no problem. But the same thing, if you put, I am putting the ascent base nozzle itself, now I am putting 50% lower, then exit pressure it will be different. So definitely you will undergo the flow separation. So that also we have to take care. For example, here Merlin 1D engine, if you take 100% is thrust is 85 ton, 100 bar chamber pressure. So exit pressure, if you assume he able to do 35% only, he is getting that. If he cannot go 30%, the main reason is a nozzle flow characteristics, flow separation. Nozzle will break because of separation or lateral load. So that is the main thing. Otherwise, the throttling reduce throttable to lower value. So the propulsion point of view also we can adjust in the injector or something that I will explain in the subsequent slide. So before now thrust is over. Now we got the delta V. That is the simple rocket equation. You take here delta V, the effective exhaust velocity. This is the overall mass including propellant. This is a final mass without propellant. So the effective exhaust velocity depends upon that specific impulse and corresponding gravitational constant. Based on this one, I worked out. Okay, this is the flight orbit inertial orbital velocity, considering the gravity turn and drag, etc. Just for schematic, this will come about 200 kilometer means this orbital velocity, it will come up to 100 kilometer. That is not a problem. So now vehicle stages worked out. If you see that, assume both are cryo stage, we assume that how much structural factor I able to get. First stage, if you assume I need a cryogenic engine, I will get 5 km per second is a velocity. You estimate that 67.1% of the initial total mass it will go to as a propellant. Remaining I will get only 32.9% only per second. So for that I have to design 8% structural factor first stage. Then only I will get to 24.9%. So second stage, again 8.7% structural factor, I will get the question. So all together, we need a minimum two-stage vehicle means 16.7 only it is possible with respect to cryo. If it is single stage, I have to do within 11% only, 11.6 only is just inert mass. Remaining propellant it will go. That is very difficult. That's why I already explained that single stage rocket they were not successful because of at the time there is no very advanced material or technology was not available. For available data, estimated Falcon 9 rocket also structural factor, the overall mass 549 ton. If first stage structural factor it is coming 5.2%, second stage is 7.8%. So this is the lowest structural factor. That's why he able to recover the stage very easily compared to any other vehicle. And the overall efficiency of the rocket also, if you take 17%, Atlas and Delta, it is 7.55, very low because the inert mass 105 ton for Delta 4, the first stage. Atlas is 72 ton, where here is 21 ton plus this payload and mass it will come, second stage mass. This is a rocket efficiency 17%. So you recalculate whether it is reaching with that number to 9.3, 400 kilometer orbit, it is coming like that. If assume if he is making single rocket like others means, he has to bring 6.6% itself, he has to do all stage inert mass. That is very difficult for meeting that requirement. So coming to the recovery process, now SpaceX, if you take, this is a pre-programmed. So if you will launch payload and again booster recovery, you will plan like this. Two type of different trajectories there. What are the trajectory? If I am launching, whether I will recover in the offshore or return to launch site, both are important. You will decide that also. If suppose he is going for sea away from launch site, so he need, this is the SpaceX profile. So he is going here, and this one burn is not required. That means he will, because of vehicle maneuver, it will bring and you will take. Suppose you want to take to return to launch site, so you need extra one boost back band for bringing back to the launch site. So this is the profile. You see here, it is going here, and he has to bring here like this launch site. So for that, after separation here, second stage, the 9 engines, 3 engines he will burn for boost back conditions. After here, he will burn. It will orientation will change. Then it will take peak altitude 70 kilometer. It will separate, but this it will go to around 120 kilometer. Then again return, and it will come to near to launch site. So again you will start the booster back band, again end here. Then after that slowly reduce the thrust, re-entry band, then again landing band. Then it will soft landing at touchdown in the land it will happen. These two profile. The difference between these two, if he is doing recovery in these CME offshore means 6% only propellant is enough. If you suppose 411 25 ton for understanding quantity, so suppose he is doing the land, that is extra 4% is required, that is 42 ton is required. So that also we have to decide a recovery where I am going to do. That customer also they will ask where we are going to do, and see recovery because high wind will come, but we are getting 4% advantage. Compared to launch site means it is better, but we have the penalty of extra 4%. So this trade-off he has to study, he has to decide and tell to customer where you want to recover. Then similarly, Falcon Heavy also to strap on, he will recover in the return to launch site, and the core motor, middle core motor, he will recover in the sea. So accordingly, you will feel the propellant in the first stages. Then what are the structural differences between expendable vehicle and recovery? So expendable vehicle, there's no this landing leg or other subsystems related one. But how it will affect with respect to aerodynamic? Gone through the literature also. So small protrusion only it will come. This is if expendable vehicle, this will not come. But recovery vehicle it will come. But since it's a stowed condition, they studied a lot of study SpaceX, and they informed that aerodynamically it is not a problem. So that's why every time we no need to do many type of internal many tests to study this one. That way he has saved a lot of money for development time. Aerodynamically there is no much effect with the expandable and recovery vehicle. Only penalty is addition, mass addition due to landing system. SpaceX 2.3 ton 2.3 to 2.5 ton only extra. And what are the technological challenges for stage recovery? If I assume that first stage recovery and the second stage recovery, first stage recovery, it is going to 70 kilometer, lot of energy embedded to the vehicle, it is reached. Again, when return, that has to bring back slowly and the re-entry missions. That's why that already retro propulsion I told. If second stage recovery, if you take, it will go to supersonic, hypersonic velocity. From there, 400 kilometer, you have to bring back. It will undergo a lot of aerodynamic and heating loads. That's why that Starship rocket is going to recover that also. He used special material for SS-304 material with the TPS he has used for Starship rocket. And that also very challenge. That's why Falcon 9 time second stage he didn't plan to recover. But now this vehicle is ready to recover that one also. And another one, even now coming to the first stage, while recovery time, because of low mass propellant will be consumed and it will be more sensitive with respect to wind and stability. This is, we all know, ascent phase, the all rocket unstable only, because then only is easy to control, like a car steering. You see here, this is a stable vehicle means it will go straight way, we cannot control. Unstable vehicle only, we can use any type of control system. We can take vehicle whatever trajectory we want. Similar way, re-entry, that overturn stability criteria is that this is a formula. The stability during landing, that means when vehicle is coming vertically, never it will come. Sometime it will tilt, or this side it will go with respect to wind. So for that, these horizontal and vertical velocity, inclination and roll, all the things we have to consider on the stage, empty stage, and also landing leg also. So that is another very challenging one. Another technological challenges, generally I want to do stage recovery means what are the required fundamentals requirement is, first we need the restart deep throttling engine. Second is that terminal navigation guidance and control, that is very important. Precise landing, I want to land within 500 mm horizontal and vertical distance. We should not go land some other locations, because we will make a platform like that. So that is very important, that navigation control. Similarly, attitude control element also, like grid fin or RCS system, all the system also we have to make. And again, landing legs, that is a major thing, recovery system, recovery one. I will come that what are the requirement for designing the landing leg. Then the refurbishment, recertification process is also very, very important. One of the example, one of the SpaceX recovery, isopropyl alcohol. After recovery, they will use for this fluid for cleaning purpose. But that is trapped, and after cleaning this one, the second time when they launch, it is propellant trapped and ignited, that causes the shutdown earlier. They able to place the satellite in the orbit with respect to other engine. Other engine is having the enough cushioning, but the recovery unable to recover that one. So that is so that's why this refurbishment properly we have to use everything. Cleaning, starting cleaning, or what I we have to use everything, we have to finalize. Similarly, another important, that engine, one of the gas generator cycle, one small 5 mm 6 mm port will be there. That also it is blocked. That also another one vehicle he was not able to recover. So that way, that the technological challenges is there for stage recovery. This all the recovery with landing leg, if you see here, empty mass of the structure very, very important. If less than 25 ton, I able to make landing leg. If you assume that like Delta-V Atlas where 50 ton, otherwise our Mark 3 vehicle also, if you take with strap on 52 ton is empty mass. So such a thing means it is very difficult to put landing leg, because leg envelope it will go to size also, and leg deployment time it will take, the energy absorption and weight and cost also. Then hard points attaching the vehicle. If it is a higher size, we need more loading point here in the structure, and misalignment and vehicle lift during landing. All the things we have to consider. And again, touchdown velocity, and already I told inclination and roll during landing. Touchdown velocity means vertical, horizontal, so all combinations is there. So like this. So we have to study everything, and this is what type of landing leg generally is available. Means this is a cantilever and inverted tripod type landing legs is there. These two number, and this is a cantilever type is a displacement, it will come very high. That's why it is not possible. And always globally they are using 4 leg with the 3 bar linkage mechanism only like this. This is the SpaceX also, it is using like that. This will give the stability or toppling chances lesser. But still, more number of legs is always good, but envelope wise we cannot put. So that the trade-off between number of leg, everything to be studied properly. But SpaceX and Blue Origin proved with 4 leg only. Suppose if mass increases, either we can go for the 6 leg, it is possible to design, but still that is complex. Then this is the landing load. It is the ground when it is coming landing leg, it's touching ground. The reaction it will come in the platform or in the landing leg. So that the shock absorbing system, all the things we have to take care. For just understanding purpose, this load in the landing leg 10 to 15 times of the empty mass. Suppose SpaceX, if you take 22 ton, it will be 250 ton is a load is coming tension compression. So we have to design buckling point of view. At the same time, joints where it will be attached here. Everything is very complex that we have to design. That's why empty mass we have to keep lesser means is always good. So Falcon 9 also before he is going, he has developed all type of technologies, and like especially he is a Griffin. He has gone for aluminum onwards. Now titanium only is using forged titanium for this one deployment purpose. It is very the pyrotechnics is using for deployment purpose. He has developed that Merlin engine, and also attitude control technology he has used, and similarly hypersonic Griffin, whatever this is a Griffin. Various types he has studied aerodynamically and structurally stable, which will provide the stability he has worked out, and successfully it is employed. Another important one, throttable engine, the thrust weight ratio means empty mass. When I am doing throttable engine, if SpaceX, if you take 85 ton is the first stage thrust, 35% is doing throttable, 29 ton is coming. So 29, but empty mass is 22. So the ratio is still higher. So when I'm when I'm firing the engine, it should be both equal. Then only it cannot hover. But if it is more means controlling is difficult. But still some other option is there. If it is more than one within 1.5, it may not go 2 or like that. We can use a terminal guidance and a landing capability by using the vehicle control system. And some system software algorithm also is using, even though higher than 1 is able to control and bring the first stage for recovery purpose. And also navigation sensor for precision landing is developed, and large floating platform also, and lightweight landing leg also. Yes, initially he has put carbon fiber aluminum. Later, because of recovery purpose, it is very difficult. He has gone for metallic only. Then thermal protection system also damage in the first stage re-entry time also he has developed and used that one. Then coming to the throttling. So earlier I told the throttling engine. Throttling also it is having some limiting factor. If you say this is a simple GG cycle, open cycle, Merlin engine also is there, our Vikas engine also is there. In that one, if you see here, fuel oxidizer is there, and this is a pre-burner. Gas generator is pre-burner. The both it will come, it will hot gases, it will run the turbine and fuel pump, and it will go to thrust injector and thrust chamber. So that way only it is a working principle. If you see here, 60 to 70% of I am reducing thrust, no stability problem. But if you go for the very lower pressure, then the injector pressure. So here each stage the pressure level it will come. The injector should not drop 25% of chamber pressure. That will create the without changing the injector flow rate. That is important. If you changing the flow rate means you have to change the geometry. So without changing, we cannot go for the lower pressure. It will give the coupling between the chamber and the field line system. That is called combustion instability. It will come, and also sputtering and popping kind of thing. It will come when you go for the very lower pressure without changing the flow rate. So and also unsteady triple like fine spray also it will come. This is the they used spindle type injectors Merlin engine right now is using compared to coaxial type of thing earlier. That's why he is able to he changed the injector with varying one 37% he able to do. But similarly earlier also lunar module diesel engine that is very fine. You should not break while landing in the moon. They used to LMDE, and this is 10% he has done throttling. There he is varied the injector. If you see here Apollo program, so varying geometry is used to be able to do, but that is a very smaller engine, 4.2 ton only engine thrust compared to our rocket first stage engines very high. So instability also is more compared to the smaller engine. So these are the challenges when you are making throttling. Even if you go for less than 37% change injector everything, again another challenge is the nozzle design. We cannot, because of Summerfield criteria, what the lower pressure is coming, that also it is very difficult to design a nozzle. That's why globally this is the 37. I think he has done now 35% is the throttling is the maximum any liquid engine throttling done still now, right? Merlin engine only. So this is the how that injector and atomizing the fuel accelerator after mixing here, it is going like this. This is just a schematic Merlin only engine, and this is the turbo pump and impeller in the how it will look. Anyway, that SpaceX how he is able to recover means he has done some of the component 3D printing that I will come later. That's why he is able to do that thrust weight ratio very high. So these all are the globally available throttable engine. RD118 47 to 50% Atlas vehicle, and Delta 4 also 57, but it's not using for the he will up and ascent pace. He will stop in between 50 kilometer 40 kilometer. You will reserve the fuel, then posting it will go vehicle, then later he will switch on restart capability. Similarly, long march Chinese also they are having 65%. Then our SSM is space shuttle main engine also they have the 65% only. So they studied below that it has the problem. That's why this engine, but they have not used for recovery purpose. While ascent base only they used this variable thrust. Merlin engine is the best optimized throttable engine. Then why other vehicles, Atlas vehicle or earlier vehicles, why they have not recovered? First of all, they never thought of recovering initial itself, but still after that also, whether is it possible to change recover whatever I told, developing all the engine, is it possible? It is not possible. The answer is it is not possible. Why means Atlas 5 rocket if you take here, this is Atlas 4. Earlier they used gem motor, solid motor. Now they changed it, and this first stage it will fire 270 second. First stage is more powerful, second stage very smaller one they kept. SpaceX if you take first stage more, but second stage also 85 ton, very powerful. So that's why it again throttable engine when we are doing, this is the difference. Strap-on also is there, is very difficult. 4 strap-on, 2 strap-on, very difficult. Even Falcon Heavy also 2 strap-on, many failure as many times he was not unable to recover. So I am taking the core alone vehicle like Boeing Starliner when he is launching, whether he is able to recover. It is not possible, because if you see here, core alone vehicle lift-off mass 305 ton. First stage 305, second stage 23, no strap-on. The payload if you take 336 ton. And thrust if you take 336 ton, here it is there 382 ton in the sea level thrust. First stage the thrust weight ratio 1.13 is there, it is able to lift off. But when I am doing throttling 47% only, it is possible here. 195 ton is coming, but empty mass 21 ton only. So what I already told, the hovering problem, all type of problem will come. Even what type of guidance and altitude if you put also is very difficult to control the vehicle, because 195 ton is there compared to 21 ton. That's why this Atlas rocket also we cannot, if throttable engine ready, putting landing leg, whether is it possible means it is not, but total stage we have to reconfigure. Similar, this is the RD180 engine. This is a very powerful engine, I already told. This is a fuel rich Merlin engine. Sorry, this is the RD180, the accelerator rich engine. This is a Russian supplied to NASA, ULA, and they are given to Delta vehicle. Americans always use fuel rich Merlin engine only, because it is having the low cost material. That is another many advantage for SpaceX. He went for very simple available semi-cryo tax kerosene engine, but he has made very lower mass, the thrust weight ratio he has increased. It is there. He has not done anything. Only throttling with injector design it is able to do. Otherwise, there is no major thing available in the Merlin engine compared to RD180. This is a very powerful engine. Similarly, Saturn 5 rocket also same 5 F1 engine 3500. Any one engine also you do throttling. Empty mass itself 130 ton. First of all, that is not possible putting landing leg etc. Parachute anything. Throttling also if you do that F1 engine thrust is very high. 280 ton it will come after throttling also. 700 ton that is one engine. 5 into 700 3500 ton Saturn which has taken the Apollo the moon vehicle. This also it is not possible. Delta 4 also still it is not at all possible. Empty mass 70 ton and they are also using one with the RS68A engine. And separately also whether is it possible like Falcon Heavy it is not possible because a throttability problem is there. Without strap-on core vehicle also same only. These all three are single same stage only is putting as a strap-on because that is called common booster core left and right side. These are Delta 4 Heavy. Earlier medium launch vehicle he has used solid motor combination also. Then Soyuz rocket, even without post strap-on, the lift-off weight is very less. It will not lift and all. Is also, if you see here, thrust is less and recovery is very difficult for them. You need strap-on. Post strap-on means again recovery with the throttle is very typical. Parachute also it is not possible. Space shuttle, I already explained. It is not. They have not used for the recovery that engine. Then coming to the how SpaceX recovered, most of things I covered that Merlin engine, only this one slide if you take a triple redundant design and fault tolerant design they used here. 3D additive manufacturing, many things they used and mass is 470 kg, 85 ton is the thrust, mass is 470 kg compared to any other engine. That's why he is able to clustering the engine and 21 ton is a empty mass, first stage. With providing the 9 into 700 ton thrust, empty mass is 21 ton. It is never done anybody. We never thought of making that one. Possibility is very lower earlier. So he has done that one. That's why he is able to recover 549 total lift of mass. And he is able to recover first stage. Then engine arrangement, if you take here, 9 engines, this is he is telling octave conditions. This is a structurally, it's a metal structure, suppose 8 engines surrounding center engine, and it will provide the high stability. And also any offset, if it is taking also, it will take care this octave only, thrust misalignment or anything. And here also is that open GG cycle means Merlin open exhaust also is there here. That side thrust it will generate turbine exhaust. That also all engines whichever firing, the side thrust it will take care. So this is the another now invention in the staging point of view he has done. So this recovery process, I will show the one figure how it will change the thrust level each step. Before going to recovery process, he has done lot of test vehicle flights like Star Hopper, Crosshopper test, and different altitudes he has done in 2015 before. And final, when you want to go for a higher altitude beyond 15 kilometers, this FAA has put on him, you should not do the test. Then directly he has taken the confidence. Parallelly, he has developed this Falcon 9 full vehicle and he has put 9 engines and successfully recovered in 2015. Now the same FA only, now he has put to hold on Starship. That is another important story. So this is recovery process, how much time it will take while ascent phase. Just for understanding purpose, I am putting here 155 seconds if it is separate. It will take 6 minutes that landing of first stage recovery. Then this is one of the video. Earlier first slide I told the 4 band how they are doing. This is a boost back band banding and then creeping deployment, but aerodynamically providing the stability purpose while returning time, and re-entry band and landing band. Finally, it is landing legs deployment and touchdown. This I will put a video after that. So this is a recovery profile, typical recovery profile. If you see here, earlier I told same way it will come and it will go. That is 320 kilometers from launch site on sea means. So it is going away from. Though he is putting recovery drone ship, whatever platform he has made floatable. This is a movable platform. you will move near to some another 50 kilometer. When it is coming, then you will move here, and so many personnel will go and collect that one. So this is the 150-second boost separation. Then flip maneuver it will come. It will rotate this stage 180 degree. Then the boost back pan you will do further. It will go to 180 kilometer, and creep fin deployment. Then the entry pan, if you see 72 kilometer, further thrust it will reduce using 3 engines. Sometimes you will use a single engine also. The landing pan single engine, all other burning you will use 3 engines. This is the altitude difference how is bringing here. So based on that one, I worked out the velocity estimation. This is burn time, that is 150 second, and separation if it is happening to bring here, it is coming to 1080 per second, 761 meter per second. Then terminal velocity where it will come here, this vehicle 2112 terminal velocity based on this is a formula you work out based on available literature data. It is coming 212 meter per second terminal velocity for SpaceX. At this point you have to fire and bring here. Then T equal to that empty mass it equal to gravity, it will come. Then further landing when you will do, it is coming 5 meter per second less than the touchdown velocity. This is a booster landings as on June 22. He has done 105 times recover reflight done. 105 in that already told 26,000 crore he is earning profit based on this recovery and reuse. Then coming to the SpaceX latest vehicle, I already told you earlier, this is the vehicle. It is moved to launch pad in June. Again, because of FAA, it moved back. Here also, the second stage recovery is putting additional the TPS developed. This is a SS tank, and initially tied with a carbon fiber tank. Then later he has moved SS304 with some tensive material he has developed for applying here. Every recovery, you will remove on the TPS only, you will apply. Like that, he is telling that it can be used for 50 to 100 times in the Earth orbit, but the ground he didn't tell. It may be lower than that one, 25 to 30 times. So this is the empty mass he is trying to do 280 ton. Keep on is working. That's why everyday test is learning from the test, taking data and again redesigning. He started with the 320 ton, now 280, and similarly Starship also. He started with around very high mass, now 120 is the target. Still, similarly, the Raptor engine also thrust weight ratio. Right now, he has claimed that 120 is further trying to improve every year. So this also it is possible to recover 280 ton, and one thrust is a 240 ton engine. So 3 engine if you do, it will come throttable engine means it will come to 96 ton. And 3 engine 280 ton, and 280 is the empty mass. Exactly, it is matching. We will able to recover easily. Similarly, Starship also, if you take empty mass 120 ton, he is putting 6 engine, and throttable if you do 78 ton into 3 156 ton and 120. So even it is going 140 also, for recovery is easy for him, but still you want to reduce the inlet mass. This is the schematic of first stage Starship. And one more very important by using this Starship is claiming that one city to other city also you transport using rocket. 100 people will go within 1 hour from anywhere in the world. That also he is claiming it is possible Starship rocket. And this is the schematic. When he told internal, many people worked out. If you go online, you see so many options. But he is also telling 100 people from Earth to lower orbit. And crew configuration also, centralized storage, common area, gym, so many things is there inside, because travel lunar to moon 3 months, and from there Mars means it will take more than 6 months. So based on that one, he has put all the facilities inside that one. So coming to the Blue Origin now. Blue Origin also, this is a single stage rocket. Here the thrust, this is a lax methane engine, single engine only is there here, 49 ton, and he is also throttable. It is possible 9 to 11 ton. So empty mass is 8 ton only. So based on that one, he is able to recover this stage continuously. I already explained, he is only using for transportation, space transportation, and some of the payload also he has put American educational payload to 100 kilometer orbit. So this is the first stage. If you go here, 84 kilometer this will separate. It's a shutdown engine. You see here, it is not visible here. 84 kilometer further posting, it will go to beyond 100. East target 100 kilometer Karman line. We go here 105 kilometer. Then again same throttable engine you will bring back here. and crew module also same. Within 10 minutes, this recovery and crew will go and come back. For that only they are paying $28 million cost that for this one. So these are the different time conditions: 15 second, 25 second. And I put a table that here, if you see here, he is coming when touchdown, very smooth velocity, 1.9 touchdown velocity, and reaching peak altitude, it will go to 1 kilometer per second only, because lax methane engine, that ISP is higher, it is taking more. So this is the Electron rocket first stage recovery parachute. This is, you see here that the empty mass, the bed mass is 13 ton only. So that's why throttable engine is not required. Sorry. So this is also 3D printed engine is using. The he able to recover with parachute and helicopter. Last time launch he was not able to recover because helicopter dropped this vehicle. This Electron rocket, the carbon, the tank and all composite, and he is also already mass production he has made, and he is also claiming that recovery means we can use minimum 10 times, but the recovery option is not there. But still, his payload cost is lesser only. Then coming to the space shuttle, because here already they used parachute-based design. So that is, if you go here, this I will go directly. This is the different altitude scheme, how it is coming here. This space shuttle, it will go 55 kilometer altitude itself, it will separate, and it will come out to other launch vehicle, it will go to 70 kilometer, 65 kilometer. So here you see here, this is the separation motor is there, that will separate. Once separated, then free fall it will come. Then the nose cap here it is there. Here one pilot parachute, rock parachute is there. So through barrow switch and the thruster is there, the nose cone it will separate. Once it is pulling, you will bring this pilot parachute, drag parachute outside. After that, parallelly here it is there, separation motor also. Here it is there. That is top locations, and after this, he is telling only 218 second, 4.78 kilometer only it is. Otherwise, it will come free ball. Then after that, this pilot parachute, whatever it is there, here it will give the lanyard is there, that will apply the force to bring the main parachute also. So all together it will deployment, and this stage will recover. This empty mass around 90 ton. So 90 ton, if you want to do parachute, the very high powerful parachute they developed, track parachute 143 ton load they designed, that one 540 kg mass, 60 meter diameter, that after expanding. Main parachute also 243 second, 1.7 kilometer altitude it will come and will expand that 990 kg, and it is designed for 88 ton. And the total, after expanding this total 41 meter diameter, it will expand that much. It will produce the drag and reduce the velocity, and it compared to the throttable engine, whatever I told, very simple engine. Here very complex system. Parachute design is very important. 279 seconds, since it is the sea, 23 meter per second it will fall down, no problem, because we are falling on the sea water. And once it fell down, if you see here bottom nozzle is open, that water it will go inside. So people will go and they will stand some 50 kilometer, and this is the scheme. It will come down, it will come down, still it will float only, water is going inside. They will go and take de-wetting they will do here after going, nearly some 10-15 people will be there, and with big personnel, very costly this recovery method. They will go on the, otherwise if they are going within 1 hour, it will go sink. This is a very complex thing. Earlier they recovered, there is no much history, fully they have not used, but based on my literature study, I found that segment 5 segments, some of the items, this is reused. Here drogues deployment, parachute, relay frustums, and all other recovered, they reused. That way they are claiming. Similarly, segment also, which is not gone water, they used here, but as it is, they have not used fully as a space shuttle SRM motor. So these are the various that retrieval operations scheme. 1 or 2 times these, since the personnel reached the correct time, it gone inside the water. So coming to the summary, this we know space industry become commercial. So reduce the cost is very important. Either low cost material, advanced method. Low cost material, because of inflation or so many things, we cannot reduce the cost of the rocket. It will go every year only. But only recovery, reuse only is a main option to reduce the cost and launch the rocket. the commercial market, it is very, very important for any space industry, the future tourism and space transportation, etc. So that video only I will put Greece. I will show
Yeah,
one
sir,
video,
you
then
can
I will close. Yeah, 2 minutes only.
Yeah, you can put it. Sir. You can put it. Sir.
So many videos is there. I able to take this all done here. So this is the one SATCOM launch in August 30, 2020. This is after return. This is a boost back band. In the it is when it is doing that one, it is going changes that one. Then it will take a peak altitude from there after separation point. The grid fin deployment here. This is a re-entry band around 40-45 kilometer re-entry band it will happen. So now started. Re-entry band reduces the velocity. Then very near to 2 kilometer landing band and then finally touchdown. Then Blue Origin also one video I will show. It is a very good video because many we thought that separation after that how much kilometer it will reach. So that the clarity is there. This is 4 June 2022. This is the only video they have shown how much velocity, altitude, etc. They never discloses the video outside. This is a Blue Origin new Shepard rocket for 100 kilometer space transportation. The 6 people went last month. So this is the 100 kilometer altitude.
Special guest astronauts.
So exciting and have a great ride.
5, 4.
So T0 minus 3 seconds.
2, 1.
So if you see here, this is the velocity miles per hour. This is a feet. 1 mile equal to 1.62 if you multiply. It is not meter per hour. So here left side it is there. You see here main engine cutoff is coming what altitude?
And Miko, main engine cutoff. The vehicle is now coasting at over 2,000 miles per hour.
So based on this only I worked out and it found that 80 kilometer is separate. Further this vehicle will go coasting more than 100 kilometer. Then Kurmat it will go separately
Okay,
and
we
the
should have
vehicle will come
separation
down.
of the capsule and the booster here momentarily.
Here,
Laura
this is the
Stiles will
separation.
cue the astronauts to unbuckle their harnesses and start floating around the capsule. Victor Vescovo, Katia Ceserreta, Hamish Harding, Jason Robinson, Victor Correa España, and Evan Dick are now in 0G. Let's listen in.
So then again
You can follow along.
This is a recovery is
Top
coming.
right corner
Many
of your
videos is
screen.
not
We
there.
just
They
heard the
were
sonic
edited
boom.
only given.
Loud and clear.
So this is the
Stop landing.
this is the recovery. You see here 134. So it is a very reduced speed and compared to SpaceX 4 meters per second, but here 1.9 like that based on this data. So very soft touchdown and recovery.
And booster touchdown. Welcome back, New Shepard. While those beautiful parachutes are essential in providing a gentle touchdown for the crew capsule,
This is a crew
New
model
Shepard
recovery that
also
is
has
separate. Thank you, sir.
Thanks a lot, sir, for the very wonderful presentation. Any questions from our audience?
Girish, can I ask one question?
Yeah, please.
Yeah. Thank you very much, Mr. Paul Murugan, for your excellent talk and the slides and videos. Really, we are very fortunate to learn many things from you. If you go to library or internet to get this much information, really several years are required for us. Now, we all understood how much effort you have put to learn all these and present to us in very systematic manner. And you had taught like a teacher to us. Now, only one question, Mr. Paul Murugan. Anytime whether crew model has failed to reach safely to land or sea, if it's so, what was the reason? Mr.
Crew
Paul
model
Murugan?
here, sir. Crew model here. Crew model. Crew
Yeah.
model that our once one times are 1984 when
Okay.
crew model when it was there it fell down. Crew
Okay.
model it is safely landed, but inside crew because of low pressure, he has died, sir. Only one condition, yes.
Where it
Because
was?
of low, Russian, sir. So is 19. Yes,
otherwise, no crew
otherwise,
model
all escaped, sir. Whenever it happened, still
very
now.
good.
Escape system is there, success rate very high. That's why now all are putting a CS system, even though we don't know when about happen and all, but that is strengthening the one more question. Space shuttle launch, sir. Whenever Soyuz American astronaut is there, they will ask whether you are going Soyuz or space shuttle. Their astronaut's wife will tell space shuttle means they will not take food for 1 week because Soyuz crew escape substance is there. Space shuttle is not there. That is one kind of story was there. The crew escape system is very important. Sir.
Okay. Thank you, Mr. Paul Murugan.
Any more questions? I think Montmasa, you can take over, sir.
Agrees on it. Still now we have shown all spaces what they have done. What we are going to do also already our chairman announced in the Gaganyaan flight. So our the test vehicle also we are developing here. That from that one it is possible to use this kind of recovery and things and all. Possibility is there. Just for information. ISRO also is working on that.
Okay.
Before vote of thanks, I really wish to congratulate Paul Murugan. That talk was really very informative. Lot of points you have compiled and you have taken effort to calculate things. And I think it is a wonderful talk and information slides also. It is full of information only. And I think we all must thank Paul Murugan for his great effort he has taken. Thank you very much.
Thank you, madam. Thank you, madam.
Any more questions? Montmasa, sir? Montmasa? Okay, if no other questions, then I think we can conclude. Let me give the vote of thanks. Paul Murugan, sir, it was actually a wonderful talk. In fact, I should say that when we approached him, so he was very happy to say that I am ready to take a talk. And I think it had delayed for 1 month or something, even after our discussion. But anyway, this much amount of information in such a 1 hour time period is something fantastic. And each of those slides, as Talavarman sir has rightly pointed out, it's a huge effort that is being reflected. And never it was a boring at any point of time, and I think it took around 1 hour and 15 minutes. But at any point of time, I cannot even ask him to say that 5 minutes more or 10 minutes more to stop, because we were just going on listening to him. I thank you a lot for accepting to us, and then giving this particular talk on reuse and reuse, and what is the importance of having such a system in our space scenario also, and how much complication is involved in developing such kind of systems, and also the cost that is involved in creating such a system and then implementing it. Thanks a lot, sir, for all the for the talk, sir. And thank you all for participating.
Thank you, Chris. Thank you, Mohammed sir and Chris.
Girish, I wanted to add one thing.
Yeah, please, sir.
In fact, I think Paul Murugan is the first person who was, in fact, offered to the young engineers in that he will deliver a talk. Normally, we used to request, in fact, he has requested, he has suggested that he will voluntarily, he has come forward to deliver a talk on this topic, and that too is a very, very informative and okay, already people have commented. So I too join Mr. Girish on behalf of the ISND Trivandrum chapter as well as the young engineers team of the chapter to express our sincere gratitude to the Paul Murugan.
Thank you, sir. Thank you, sir.
Okay, then we can wind up. Thank you, sir.
Yes, sir. Yes, sir.
Okay, thank you. Thank you all for joining this meeting.
Thank you all. Thank you.
Thank you. Thank you.